All right, so we've ran some basic checks and we're good to go as far as errors go. What do we do next? Well, just because we're receiving a token, or a transfer, I should say, from the EOSIO.token contract, and we know who it's coming from and where it's going, it doesn't necessarily mean that we're getting wax, right? Because this contract, it might have several different tokens on it. Like the Our Planet one that we looked at before, it had like 7 tokens on it. So just because we're receiving a transfer from this contract doesn't necessarily mean that we know what token it is. So let's say, for example, we want to only accept wax on this contract, right? We want to make sure that we know what the wax symbol is, and we want to make sure that the token we're receiving is wax. Well, first we have to define the wax symbol. So let's go up a bit, and up here where we're defining stuff, we'll do some more copy and paste. So this right here, I know the syntax is a little weird as far as symbols on wax, but this is how it goes, right? So a symbol is comprised of 2 different things. You have what's called a string view, which is what you know as just WAX, wax, right? So that's formatted as a string view, not a string. And then you have the decimals, which is formatted as unsigned int 8 underscore t, and that would be the amount of decimal places or the precision that the token has. So the token symbol is actually a combination of the string view, which is wax, and the precision, which is in this case 8, but obviously it's different for different tokens. And then you have the final symbol, which you've defined by combining these 2 things together, the string and the decimal places, which is formatted as a special thing called a symbol in EOSIO library. So we've just defined this. We now know what the wax symbol is, and we've named it right here, wax symbol. We could change the name of this if we wanted. We could call it token we want, right? But we're going to call it wax symbol. And then now, one more check that we can run is to make sure that the symbol matches. So we can say check. And I guess now's a good time to go over the asset class in the EOSIO. An asset is a combination of a uint64t, which is just a number basically, and a symbol, which I just told you what that is. So an asset would actually look something like this. 1, and then you'd have to put, all the decimal places, and then wax. So this is kind of what 1 wax looks like inside a contract. You'd have to have 8 decimal places plus the 1, and then the string view wax. If you had it looking like this, 1 wax, it has 8 decimal places, right? So this doesn't make sense. This would probably be interpreted as something like this. That's what it would be interpreted as, because it has 8 decimal places. So what you're really saying is one wax isn't really 1 wax. It's 0.00070 zeros and then 1. That's an asset. That's what an asset is in wax. So in order for you to access the symbol inside of that asset, how do you do that, right? How do you check inside this quantity variable right here? We're receiving a quantity, right? How do we check the symbol of that quantity? Let's say we receive 10 wax. Well, what we would do is just say quantity. It's very simple. Quantity dot symbol. And then all we have to do is make sure that that's equal to the wax symbol that we just defined. So check quantity dot symbol equals wax symbol. And then the error message we would give would be like, symbol is not what we were expecting. Right, so now we know that we're getting tokens from the correct contract. We know for a fact that we're not sending them. We're actually receiving them. And then we know the symbol matches. So now we know that we're receiving wax from the EOSIO.token contract. Now we can actually move forward with stuff and do what we want to do. These are just basic checks. So what might we want to do with this wax now that we've received it? Well, that's going to depend on a few different things. It depends on what our contract is designed to do, really, right? We could do anything. It's pretty typical that a contract would do multiple different things based on some criteria, right? So normally there's a memo included with the transaction. So it might say something like deposit or purchase, something inside the memo. But that's if you want to process different kinds of transactions. We'll get to that in a bit, but for now, let's keep it simple. Let's just do something basic. We're not worried about the memo right now. Let's just say that we want to store some information in a balances table. How about that? So why don't we go back down and just create a new table. So we're going to copy all this whole entire first table here, this messages table, and we'll create a new one called balances. And remember, it has to be here, but also here and here. You have to make sure these and this are all the name. And then we're going to create a name that we're going to use to access it. So we'll say bal table. And let's see. For the primary key, I guess now is a good time for us to go over some indexing a bit. So for primary keys, you have a few options. You can't store a name as a primary key, like not directly anyway. You can't just, let's say the person sending the wax to us was Mike D Crypto 5. You can't just store Mike D Crypto 5 as the primary key because that's a name that's not compatible with primary keys on tables on, EOS and Wax. One option, and the most common option, is a UNT64T for the primary key. There's a couple other ones. I'm not going to go over like every single one in this video. I honestly probably don't even know every single one, but I usually use a UNT64T for the primary. So what you can do, we can call this user. The primary key would be called user, and we have to make sure that in our little primary key function down here, we make sure to return user now. And now what we can do in order to store that, because a name like Mike D Crypto 5, that's not a UNT64T, right? That's a name. So how do we store user here if it's not a number? That makes no sense, right? Well, here's what we'll do. Let's copy this in place info function here that we use for the messages table. We'll just put it up here into this on notify EOSIO token function, and we'll say bal table bals, and we'll keep the scope the same and the table the same, or the table the same and the scope the same, I should say. So we'll just use get self and get self.value for those as usual. And then we'll say, well, we don't want to just do it in place, right? Because primary keys need to be unique. So we run into an issue here. What happens if this user is already in the balances table and we try to in place means insert. If we try to in place the user again and they're already there, it's going to give us an error. It's going to say that you have a uniqueness constraint or something along those lines. So what you do is people refer to it as like an upsert, like update/insert. So first we're going to look in the table and see if the user is there. So we'll say auto iterator equals, and now we're going to search the primary index of the bals table here. So we'll say bals.find. And now inside these parentheses, we have to specify what it is that we're looking for. So from right here, that's the person sending the asset to us. So we are going to try to find from dot value. And I'll get into dot value a bit. Well, you know what? I guess I'll get into it right now. It basically just converts a name to a UNT64 format, UNT64T. If you don't really know what that means, just put it this way. Names can be represented as a numeric kind of string looking number. So it's basically going to take the name, convert it to a number, and then it's going to store that as the primary key. When you look at the table on the blockchain, it would look, well, I don't see anything here that matches, but it would look like a number. You're not gonna look at it and it's not gonna say Mike D Crypto 5. It's gonna say like 34758 blah blah blah, a bunch of numbers. But that's fine because it works for our purposes. It's still gonna tell us if the user is in the table. and then we can move from there. So we'll say if the user is in the table, so we'll say if iterator does not equal vals.end. That means this iterator that checks the table, if it doesn't go all the way to the end of the table, and it actually did find the user, then let's do some stuff. And in here we would do like modify this user's entry. And then we can say else if the user's not in there, then we're going to place the user as a new user. So first let's do the in place. And we're going to get rid of this message field here. So let's go back down to the table. We don't need a message in here, right? All we want, let's say we want a user and their balance. That should be enough, right? So we'll say for the second column in the table, we'll do EOSIO asset, and we'll call it balance. Right, there we go. So we've got the balances table with a user column and a balance column. And the balance column has to be formatted as an asset. Well, let's go up here and if we do the in place, we're inserting a brand new user that doesn't exist yet. We'd say that the user field, so row.user, it's not going to just be available primary key this time, right? Because we're actually using the username .value. So we'll say row.user is from .value. That just means the numeric representation of the person who sent the asset to us. And then we'll say row.balance equals quantity, because that's the asset up here. That's what we're getting. And you know what? We might also want to check one more thing that I didn't mention before. I know the EOSIO token contract does this anyway, but you never want to be too sure. So we can also just add one more check. Check quantity.amount. This is how you access the number is greater than 0. And then we'll throw an error that says quantity must be greater than 0. All right, so now we know we're actually receiving a positive value. So if we didn't find the user in the table, we're going to in place them. Or else, if we did find them, what we're going to do is copy this same thing, this whole in place function right here, and we're going to paste it into where we modify. And instead of bals.inplace, we do bals.modify. All right, and in here, you see how you have the RAM pair, and then you have the little lambda function. Well, we have to, when we do a modify, there's one other thing that you have to specify here, right? Because what are you modifying? You have a whole table. All you're saying is modify something in this table. Well, which record, which row? Iterator, right here. Iterator equals find this user. Iterator is our pointer. This is what's going to tell us everything about this user. So we do modify iterator, comma, and then you define the other two things. So now we know which row that we're actually going to modify. It's the iterator that we just specified up here. We don't need to call the user row anything. We don't need to change that because it's already defined. So we can just erase that right from that function. All we need to do is change the balance. But we don't want to make the balance quantity, right? Because, well, what if there's already a quantity in there? What if the user already has 2 wax as their balance and they just sent us 1 wax? If we say row.balance equals quantity, then that means we're changing it to 1 wax. We don't want to change it to equal the quantity. We want to add the quantity to it. So we'll say plus equals quantity. Row.balance plus equals quantity. What that's going to do is add the asset to the asset that's already in there. And now, so if the user had 2 wax and they sent us 1, it would update their balance to 3. And now I guess now's a good time to talk about this RAM payment situation. Let's say you wanted to in place into the table, right? This user sent us some wax. We want to add a record for them. We don't want to pay RAM though, because let's say we're providing some like free service or a very cheap where we don't make any money. Well, if we have to pay RAM for every single transaction we receive, we're setting ourselves up for failure, right? We're going to lose money. We'll go bankrupt in a week. So how do we go around this? Can we just change get self right here, the RAM payer? Can we just change this to like from, and then now we're charging the user? Well, in the add message function right here, you could do that. You could change messages.inPlace to equal this user right here. We're requiring their authorization for this transaction. They're signing it. We could change that so that the user pays for that. Because this is a direct action on our contract. This is our action. We define this, right? This is us doing this. In other words, the user is interacting directly with our contract. They're going to our contract. They're saying, I want to do this transaction with you, code tutorial, and I'm willing to pay some RAM. That's basically how that works. So you can actually charge them by just putting user right there. Now up here, this is different. This is not an action on our contract. We're reacting to something. The user interacted with the EOSIO.token contract. They didn't give us permission to do anything. So we can't just go and charge the user for something where they didn't even interact with our contract. All we're doing is listening for something to happen. We hear that it happens, and then we do something. We're storing information in our table. If you could just charge people for that, what a security flaw would that be, right? So you can't do that. So for emplacing a new user here, you have to, the only person who can pay RAM here is you. So we have to change this back to get self. However, there is a thing called in the modify function up here. When we're modifying, there's already someone who paid RAM on this entry, right? If we go to the just a random table here on the EOSIO.token contract, there's a balance, and you can see who the RAM payer was. This name right here. Well, if you change this right here, there's a thing called same payer. And what that's going to do is it's going to keep the same payer. Exactly what it sounds like. So let's say you had done something previously, right? Like this add message action. And you charge the user for creating this message, which you can do because it was a direct interaction with your contract. And then they sent you some tokens, and all you want to do is modify the record that already exists. Well, in that case, you can charge the user because you're not actually charging them. You're updating an existing record. So you can just say, hey, I want to keep this as the same payer as before. I don't want to charge a new person. Just whoever paid for it previously, just keep them as the payer. Now there's one catch or caveat with this. You cannot increase the RAM price of this row. So I mentioned that in asset, we have the balance right here, right? The only thing that we're changing in this update that we're about to do is their balance. And this is, like I said, this is a combination of a symbol and a uint64t. Well, a uint64t is always 8 bytes. You might be confused by that, but basically it means the data size. Like even if you increase the number, let's say they originally had 1 wax and then it changes to 100 wax. Well, you might look at that and think, oh no, 2 more digits got added. But that's not really how that works. It's still a uint64t. It's still the same data format, which means the amount of bytes it takes, the amount of space it takes to store that data has not changed. It hasn't increased. It's the same amount. So you can keep the same payer there. However, for something like a string, this message right here, for example, a message is a string, and that's just basically like the amount of characters is the amount of bytes or something along those lines. So if the original message was, this is a message, right? The user pays the RAM on that. Then they send a transfer to you, and then you try to change it to like, this is a message 1, 2, 3, 4, 5. Well, you've now added 6 more characters technically, which means you've added more bytes, which means the cost of RAM to store this information has now become more than it was previously, and you cannot do that. That is not acceptable. The transaction will fail. You cannot increase the amount of RAM that you're charging a user, even if they were previously the payer on that row. So there's some clever ways to get around this if you're like very sure of what's going to happen. For instance, sometimes what I do is inside my table, I might have, like in this messages table right here, I might have a third column, called like string filler data. And like if I know exactly how much space I'm going to need to store someone's information inside this filler data tab, like on the first in place when the user pays for it, I might do something like row.filler equals a bunch of characters, because what's going to happen there is the user is now going to pay for this to store this data. And let's say I'm expecting, a transfer from them, and I know for a fact that it's not going to be any bigger than this string right here. Well, what I'll do is then when they send me a transfer and I go to modify their row, I'd say like row.message equals, and now I increase the size of this, but I can't just do that I can't just charge them, right? So now I have to row.filler equals just empty now. So even though I'm adding to one row, which I wouldn't be able to do, I'm removing this much from another row. So the user is actually probably getting a little bit of RAM back now. So it's a good workaround for if there's like a reason why you might need to charge RAM and increase the amount of data being stored upon reacting to some action. So yeah, that's how you do that. Anyway, let's get rid of that stuff. Okay. So I think everything is correct. So let me compile the contract again. String view, wax string, unknown type string view. Oh yeah. So we're using the namespace, whatever namespace we're using at this point. So I just have to say standard string view, and then now it should work. And there it goes. So it's compiled. And now if I want to redeploy this again, I just need to unlock the wallet again. Unlocked. And now we just want to deploy again. So I'm just going to, it's the same command as earlier. I'm just going to hit the up arrow a few times on my keyboard and just go back to the same command as before. Deploy it to the testnet, hit enter. Should have enough RAM still. I got 500,000 bytes, and there you go. Now if we go to code tutorial account on the blockchain, it should show that, look, set ABI and set code. These transactions are still processing now. That means our transaction went through. And if we go, it might just need to refresh to show the new table. And there, now we have a balances table with nothing in it, just empty. So let's test this out by sending some tokens. Remember that we said if we are the sender, we don't want to do anything. So we're not going to send from our own account because that's not going to do anything. We accounted for that. So let me log in with another wallet. And I'm now logged in with Mike D Crypto 5. So let me open another tab. And if I go to my wallet here, I'm going to send, let's just say I send 3 wax to Code Tutorial. And Code Tutorial should react to this and store some information in the table. Now if we go back to Code Tutorial, the balances table, and hit refresh, look at that. See, this is, like I said, this is the weird numeric, this is the dot value of a username right here. This 1063 blah blah blah, that's dot value. When I say from dot value or user dot value, that's what it looks like. It doesn't look like Mike D Crypto 5, it looks like a bunch of numbers. And you can see the balance is 3 wax. And now if I send more wax, it shouldn't add another row, and it shouldn't change the balance to be the new amount. It should combine the old amount with the new amount, because we did plus equals quantity. So if I send, let's say, 2 wax now, it should change to 5 wax as the balance for Mike Decrypto 5. And if we hit refresh, there it is. So now we're accepting tokens. We're reacting by storing information in a table. And what else could we want to do? Maybe we want to send something back to the user. So instead of wax itself, how about we get another token defined here? Let's see, what tokens do I have in Mike Decrypto account? I've got some waxed out tokens. All right, 290 waxed out tokens at MD Crypto NFTs. Those have 8 decimals. So what I'll do here now is I'll have to define another symbol. I'm just going to copy and paste the wax symbol definition there, that whole variable, and I'm going to create another one called, let's see, we'll call it wax DAO string, wax DAO decimals, wax DAO symbol. And then we have to make sure we put the right names inside the symbol definition. Now, the wax DAO token also has 8 decimals, so I'm going to leave that how it is. But other tokens, some tokens have 0, some have 4, you know, it could be anything. And the string itself is wax DAO for this token. So after we do all this stuff, how about, let's say we want to transfer the user, let's say we want to transfer them 1 wax DAO. Or how about the same amount of, yeah, we'll say 1 wax DAO. And we're going to run into another problem here, by the way, before I even get started with this. We need to have a special permission on our contract called the EOSIO.code permission. This allows our contract to send tokens on our behalf without us needing to actually sign a transaction, right? Because your contract is just going to try and send off tokens to someone. Well, it can't just do that. It needs a signature. In order for us to bypass that and allow this to all happen automatically, we have to add a special permission. And we can do that from right inside the terminal. I'm just going to have to find my file that I copy paste this from. All right, and this is it right here. So CLEOS, and then you're going to put the U flag and specify the node you want to submit this to. That's how I do it anyway. So we're going to be submitting this to the testnet because that's where I want to do this. And then it's set account permission, the name of the account, which is code tutorial, the permission, which is active, like the permission that you're signing with your active key. That's what I'm doing anyway. And then add code. So this is how you add that special code to give the contract permission to send tokens. So if we hit enter, don't be locked. Executed locally but may not be confirmed by the network yet. So it looks good. And if we go to code tutorial account and we look at the keys, well, right now we just have normal keys, but if I refresh the page, we should see a new permission here. Code tutorial at eosio.code is now in the active section. That means we've got that special permission, and our contract will now be able to send tokens on our behalf on the testnet only right now. All right, so we have to actually make this transfer function. All right, so in order to actually do this transfer, you have to just create an action right here. I mean, this isn't actually the cleanest way to do this. I would probably have to define somewhere else and just call it. But, you know, I'm just doing this for tutorial purposes. I wouldn't normally just write this out right here. But you create an action, and inside the parentheses that go from beginning to end, first you have to define the permissions that you're using. So we're using code tutorial active permission. And, you know, by the way, just as a reminder, all this code is going to be in the description below. So don't worry about like watching the screen and writing this all out. You can just go to the description. You'll be able to copy and paste all this stuff. But first we're specifying the code. So code tutorial, active permission, and then which contract are we calling? MD Crypto NFTs is where the Wax DAO token is stored. Right here, MD Crypto NFTs. And the action that we want to call on that contract is the transfer action. And pay attention. All these things are names here, so you have to put the underscore n after every one of them. All right, and then we have this thing called a tuple. If you don't know what a tuple is, I suggest just watching some C++ videos, but it's, pretty much just a combination of different variables here. So inside this tuple, we've got who we're sending from, which would be us, code tutorial, and then who we're sending to. And we're sending to the from variable. Remember, when we listened to this transaction, we take in a name called from. That's the person who sent us the wax tokens. So that's the person we're going to be sending back these wax DAO tokens to. And the third field is the amount or the quantity, which is an asset. This is how you kind of define an asset if you want to. There's other ways, but asset, and then inside the assets parentheses, you just put the amount and the symbol. We define the wax DAO symbol up here. And as far as the amount, this is 1. Remember, wax DAO has 8 decimals. So you have to put the 8 zeros and then the 1 in front of it. That just means 1 wax DAO. If wax DAO had 0 decimal places, you would format 1 just by putting the number 1. Because if it had 0 decimal places and you put it like this, you actually would be sending this amount, which is like, I don't know, what is it, 100 million or something like that? 100 million. So be careful with your decimals. Make sure you know what you're doing with that stuff. And then the last thing is the memo. And that's just a string. And we're just going to say, we just reacted, son. And then .send at the end. That means, all right, we defined this action. Now we want to actually send it. So this should send somebody 1 wax DAO whenever they send us some wax. And how about on top of this, just to, because, somebody could send us like the bare minimum of wax and get 1 wax DAO from it. We might not want to do that. So how about, instead of saying quantity must be greater than 0, how about we make it so they have to send us at least 1 wax? So let's change this to 1 and then the 8 zeros. And then quantity must be greater than 1 wax. So now, in order for somebody to get these wax DAO tokens from us, they have to send us at least 1 wax. So let's save this. Now we have to compile the contract again. Now we have to deploy it again. And if we refresh the page, we should see a new transaction, set code. All right, so you notice how earlier we had set code and set ABI, both of those files, and now this time we only have set code. How come? Well, that's because we didn't create any new actions. The ABI file didn't actually change. The ABI is just like a definition of all the structs or all the different actions in your contract. Add message, on notify. We didn't add any new things. It didn't change at all. It's the same. So that's why it didn't get updated. Update auth here, this permission. This was us adding that EOSIO.code permission earlier. All right, I just realized something. The code tutorial contract doesn't even have any wax DAO tokens right now, so this transaction will fail no matter what. But that's okay. Let's first just try to send less than 1 wax. So we'll send to code tutorial 0.99 wax. And it should say that we got to send at least 1. Failure with message. Quantity must be greater than 1 wax. So that's working. Now let's try it with 1. And it should fail because it's going to say insufficient balance or something like that, or a balance object not found. And that's because code tutorial does not have any wax DAO tokens. Quantity must be great. Oh, I set it to be greater. I should have set it to be greater or equal to. I'll fix that later. But for now, we just have to send 1.01 wax. Then let's do. No balance object found. Exactly like I said. That's not a problem with Mike Decrypto 5. That's a problem with code tutorial. So let's just go to Mike Decrypto 5 now and send. Let's just change the token here to wax DAO. Let's send like 100 wax DAO to code tutorial. All right, so now code tutorial should have a balance, and we can verify that if we want. All right, code tutorial's got 100 wax style. You can see it right here. Now this transaction should work. If we send 1.01 wax, we should receive back 1 wax style. And our balance should also get updated in the table. So first let's check that. Now it's 6.01. That's correct. And let's go to our account. Refresh it. Receive token. We just reacted, son. Cool, right? So we sent 1.01 wax and we got back 1 wax style. So now you know how to listen for events, react to a notification, do a token transfer inline. This is called an inline action. This one down here. Inline just kind of means like we've already created an action up here where we react to something. Now inside of that, inline, we do another action. So you learned how to create an inline action. That's what this is called here. An inline transfer. And that is how you do that.